Hello everyone. So today we'll be solving paper of March 2023. So without wasting any time, let's get started. Paper is March 23 and question. So let's start with the first question. It is asking us to make a cumulative frequency. So the first thing that we do is first we make a table for the cumulative frequency. How do we do that? Cumulative means total. So if I were to make 1, 3, 5, 6, 7, and 8. Okay, now let me take x, and here I'll write cumulative frequency. So that means how many values do I have which are less than 30? None. How many total values do I have which are less than 16? 4. How many total values do I have which are less than 90? 12. How many values do I have which are less than 110? And by adding 12 and 14, we get 26. And how many total values do we have which are less than 140? So 26 plus 25 is 51. And how many total values do we have which are less than 180? And that is supposed to be 51 plus 7 is 58. And how many total values do I have which are less than 240? And that is 2. Now, these are the points that we plot on the graph. I use an Excel sheet to make a graph out of this. You have the graph paper with you. You can easily do that on your graph. So I have 30, 0, x-axis we have the value of x, and on y we have the cumulative frequency. So I have 30, I have 0, and I have 60, I have 4, and 90, 110, 10, 180, and 240, 12, 96, 51. Okay, class. So once we have plotted all these values, we get a smooth curve in this way. We can start the graph from 0 as well. This is the kind of curve that we'll end up with. We paste it over. Class. So this is the kind of graph that we get once we plot all the points. Okay, then moving on to the next part. The question says, use your graph to estimate the 70th percentile of the data. How do you find 70th percentile? How much data did we have? How many people did we have? We had the, oh, sorry, not the people. How many years did we have? We had 60 years, the data for 60 years. So 70th percentile means we'll need to find 70% of 60, which is 42. So what do we do then? From our graph, we read 42. You'll have the graph with you. Read 42 and you'll say the value that you get, this will be your 70th percentile. So this value is supposed to be around 125, 126 if you have the exact graph. So this value will be 126 class. Moving on, in part C, question says calculate an estimate of the mean number of hours of sunshine in Kinto during June over the last 60 years. Now we need to calculate the mean number of hours. Okay, how do we go about doing that? This is how we write mean. Okay, now the main thing is that 4 years when sunshine was between 30 to 60 hours. What do we do with that? These are the 4 years when the sunshine was between 30 and 60. So we estimate that all these 4 years had the sunshine exactly between 30 and 60. So what is between 30 and 60? We can add both of them, 30 plus 60, and we divide by 2, we get 45. So we'll simply say that 4 will multiply by 45, we'll take the middle values. 12 will multiply, 8 will multiply by 75 plus 8 times 75 plus 14 will multiply by 100 and 150, 250, 125. 25 will multiply by 125 and 7 will multiply by 160 and 240, 210, 40, 60, 300. 2 will multiply by 2. 2 will multiplied by 210, and all of these were total years were 60. So we get the mean as use the calculator. We get it as 140. So this is how we do question number 1. Moving on to question number 2. Question says that, write down the question first. Okay, Alicia has 4 coins. One of these coins is biased so that the probability of obtaining a head is 0.6. The other 3 coins are fair. Alicia throws the 4 coins at the same time. The random variable x denotes the number of heads obtained. Show that the probability of obtaining exactly 1 head is 0.225. Okay, now what do we need to do? We need to figure out that she gets only 1 head. How do we do that? Okay, so one way of doing it is that you can say that she gets head on the biased one, or the other one is head on any fair. Right, so first let's talk about if she get head on the biased point. So we will say that we get head and then tail and then tail. So how do we calculate it? Head is 0.6 and the remaining three are tails, which is 0.5 to the power 3. What if she gets head on any fair coin? So if she gets head on any fair coin, that means tail on the biased one and then head on any one. So for one of these settings, I'll say that if she gets the tail on the biased one and head on any of the fair one, then the tails, which is equal to, and then this can occur. The arrangements for these head, tail, and tail is 3 factorial divided by 2 factorial. Because these are 3 head, tail, tail, these 3 can occur in any possible way. Let me color code the biased one. I'm color coding it as red. And once you add both of them, bold exactly color. So these are the total number or the total probability that I get if I add both of them. So I'll simply say that just add all of them and we'll end up getting 0.25. It's already provided. Okay, moving on to part B of question number 2. Complete the following probability distribution table. Okay, the question has already asked us about the one head we already have added. Okay, what about 3 heads? How do we get 3 heads? Again, what is the possibility of getting 3 heads or 2 heads? If we start with 2 heads as well, we can also calculate 2 heads first. And we need to find 2 heads and 3 heads. So we are saying we find probability x is equals to 2. Again, 2 heads. What are the settings for the 2 heads? If she gets a head on the biased one and another head and any 2 tails. Again, head on the biased one is 0.6 and 0.5 on the fair one and then 0.5 square. And then this can happen in impossible order. So for and again, I'm considering the order for the fair ones only. I'm not counting this in the order that we talk about. So once we take 0.6 into 0.5 square and then into 3, the value that we get is 0.375. And then we can simply find probability x is equal to the 1 minus 0.05 plus 0.225 plus 0.375 plus 0.075. So you get probability x is equal to 3 as 0.275. Okay, class. Given that the expectation is 2.1, find the variance. How do we find the variance? We already have the formula. What do? We just square the variables. For example, we take 0 square and we multiply it by 0.05 plus 1 square multiplied by 0.225 plus 2 square multiplied by 0.375 plus 3 square into 0.275 plus 4 square into 0.075 minus the square of expectation 2.1 square. The formula is already provided for discrete random variable in MF19. You can refer to that. And we get it as 0.99. Okay, class. Moving on. The next question that we are looking at is "80% of the residents of Kinwa are in favor of a leisure center being built in the town. 20 residents of Kinwawa are chosen at random and asked in turn whether they are in favor of the revision. Whenever you see that the trial or the sample is fixed, I can simply say that the residents are binomially distributed, whether they'd be in favor of the center being built or they'd be against it. So I've taken 20 residents and the probability of success that the resident will be in favor is 0.8. Find the probability that more than 17 of the residents, so the question says more than 17, which would mean that either 18 residents or 19 residents or 20 residents. So we'll have to apply binomial 3 times. Okay, for 18, again, the formula is provided. So let's just do it that way. Okay. So we go 20 C18, and then the success has the power of 18, and the failure, which is 0.2, is the power of 2. Again, we do the same thing for 19. And for 19, we just say that the success has the power 19 and the failure has the power 1. And then we say that success has the power 20. So the probability x is greater than 17 will yield up getting 0.206. Moving on to question number 3, B. Question says find the probability. Let me just copy the question here. Find the probability that the fifth person asked is the first person who is not in favor of the leisure center. Now they have just converted the same thing into geometric distribution. Again, I write the notation just for your ease. X, I can say now it is geometrically distributed, probability of success being 0.8. So the question wants us to get the success in the fifth one. So if we want the fifth to be the success, we would want first 4 failures to occur, and then we would want fifth to be the successful one. So what is the probability that we get success in the fifth one? It is 0.0819. Okay, sorry, my bad. The question is saying who's not in favor of the leisure center. Not in favor. Okay, now the probability of success is 0.2. The person who is not in favor. Okay, so this is how we'll calculate it. And we'll end up getting 0.0819. Okay, so part C then says find the probability that the seventh person asked is the second person who is not in favor of the leisure one. Again, now this is possible with different orders, right? This is possible with different orders. In either way, I'll say that I get failure 5 times and success 2 times. Now, how is this possible? Let me write different ways just to make you people understand that how are we dealing with this. Okay, I can say that first and then the second one was 7, or I can say that second and 7th. I'm talking about the people who are not in favor. And then I can say third and 7th, and then so on. So how many different possibilities will we get for this? We'll get 6 different possibilities. So whatever probability we have done, we'll say it will be either of the 6. So you just multiply it by 6. And then the answer that we get is 0.0786. Let me write all of this for you. 4 and 7. And then I'll say fifth and seventh, sixth, and these are the 6 different variations that were possible. Let's moving on. The next question is a long one to read, so just give it a read before we start with the working. The probability that it will rain on any given day is X. If it is raining, the probability that Aaron wears a hat is 0.8, and if it is not raining, the probability that Aaron wears a hat is 0.3. Whether it is raining or not, if Aaron wears a hat, the probability that he wears a scarf, if Aaron wears a hat, he wears a scarf is 0.4. If he does not wear a hat, the probability that he wears a scarf is 0.1. The probability that on a randomly chosen day it is not raining and Aaron is not wearing a hat or a scarf is 0.36. Find the value of X again. If we just make a very small probability distribution, just a tree diagram, we can say that whether it rains or it does not rain. So we are making 2 branches. I'll just draw it and then I'll paste it. It rains or it does not rain. So the probability of rain is X. The probability that it does not rain is 1 over minus X. And then we say that he either wears a hat or he does not wear a hat. Again, he wears a hat or he does not wear a hat. Okay, then we will say it's hat or had not, had or had not. Okay. If it is raining, the probability that Aaron wears a hat is 0.1. Not raining, he wears a hat is 0.8. This probability is 0.8. So this one will be 0.2. Again, this tree is just for our own understanding, 0.3 and 0.7. Okay, now irrespective of the fact, the question is telling you that now he either wears a scarf or does not wear a scarf. Wears a scarf, does not wear a scarf. Wears a scarf, then no scarf, and then scarf or no scarf. Again, we'll not try to fill out each and every detail, but we'll just try to understand that he wears a scarf or no scarf, scarf or no scarf, scarf or scarf, scarf, no scarf. Now the question says that whether it is raining or not. If he wears a hat, the probability of wearing a scarf is 0.4. If he does not wear a hat, 0.4 and 0.1. So this is 0.4 and for remaining all the calculations are done accordingly. Scarf, I'm not filling out all the probabilities for a scarf and no scarf. You just try to understand it with this particular way. Okay, class. Now the question says that it is not raining. So the question is telling you that no rain and not wearing a hat. You could have also done all of this without the tree and not wearing a hat or a scarf and no scarf. This probability is 0.36. This is 0.36. Okay. So no rain, that means 1 minus x, and no hat is 0.7, and no scarf, without the hat, no scarf is 0.9, and so 0.36. So if you solve this, what is the value of x that we get? You can easily solve it and get the value of x, which is 3 over 7. Okay. Moving on to the next question. Marco has four boxes labeled K, L, M, and N. He places them in a straight line in the order K, L, M, and with K, L, M, N with K on the left. Sorry, and he places them in a straight line in the order K, L, M, N with K on the left. Okay. Marco also has four colored marbles. One is red, green, white, and one is yellow. He places a single marble in each box at random. Events A and B are defined as follows. Event A is the white marble is in either box L or box N. B is the red marble is to the left of both the green and the yellow marbles. Okay, now you need to understand the order with which these things are occurring, right? Okay, let's find the probabilities of both the events first. What is the probability of A? How does event A occurs? We're talking about event A. The white marble is in either box L or box M. Again, the question says that if the white one, again, the white one will either be K, L, M, or N. So out of that, we have two favorable, and probability of A will be 2 out of 4. So this will be 1 over 2. Okay. Then what about event B? Event B, we will say that probability of B is the red marble is to the left of both the green and the yellow marble. So that means that the left marble, the red marble will either be in K or L. The red marble is to the left of both the green and the yellow marble. Okay. Event B, we'll have to understand it. This is how these are the four boxes. Okay. K, L, M, and N. Now, when we try to place the marbles in them, if red is here, again, red is here, or red is here, and then so on. Let's try to simplify it. So if we keep red in the first one, then the three marbles can be arranged in any particular way. That will be 3 factorial, which is 6. Okay, what if we keep red in the second one? We keep red in the second one, and white has to be over here, and the remaining can be 2 factorial, which is 2. So the favorable outcomes are 8, and the total outcomes can be 4 factorial, which will be 24. This will amount to 1 over 3. So the probability of B is again 1 over 3. Okay, next we need to find probability of A intersection B. The events when both are occurring. Event A is occurring and event B is also occurring. The white marble is either box L or box M. Okay, now the first one, the one where we have taken 3 factorials, which means these 6. Now out of these 6, there would be some arrangements when the white marble will be either in box L or box M. Okay, if I keep out of these 6, how often we get white once over here, or 2 times white will be over here, and 2 times white will be over here. So that means there will be 4 arrangements. You can also count it. Okay, class. So if the red one is over here, and the question says that white is supposed to be in box L or box M. If the white one is in box L, then green and yellow can switch between M and N. Or if the white is in box M, then green and yellow can switch between L and M. So these are the 4 possibilities when I get both events A and B. And out of the 24 possibilities that I have, which means 1 over 6. And if I take their individual probability of A and I multiply it by probability of B, which is 1 over 2 times 1 over 3, I again get 1 over 6. So if both probability of A intersection B is equal to the probability of A times the probability of V. That means the events are independent. I hope this is clear. Okay, let's moving on. In a cycling event, the times taken to complete a course are modeled by a normal distribution with mean 62.3 and standard deviation 8.4. Find the probability that a randomly chosen cyclist has a time less than 74 minutes. I've always advised my students to make simple bell curve to understand normal distribution and attempt the questions. So the mean will be in the center, which is 62.3, and 74 will be somewhere on the right of 62.3. 62.3 and 74. 74. And what are we trying to find? Less than 74. So this is the area that we are interested in. The area which is less than 74. I'll just share the image here as well. This just gives you a rough idea of what you need to do and how you need to do it. Okay. So the first thing that you're supposed to do is find the Z value. When X is 24 or 74, sorry, 62.3, and this divided by standard deviation, which is 8.4. So the value of Z that you will get is 1.393. 1.393. And once you read it from the normal distribution table, you'll end up getting 0.918. So this is how we do the first part for discussion. Moving on to the second part, find the probability that 4 randomly chosen cyclists all have times between 50 and 74 minutes. So let's talk about a single cyclist first. We know the area or the probability that lies when it is before 74. So now we need to find 50 and we need to find the probability that the cyclist time is between 74 and 60. So I'm just writing it over a time. I'm taking it as T. It is normally distributed, mean is 62.3 and variance is 8.4 square of that. 8.4%. So first we need to find the probability that the time is between 50 and 74. We already know what is it before 74. So first we find the Z value when it is 50. 50 minus 62.3 divided by 8.4. So the Z value that we get is minus 1.464. Minus 1.464. Now we know that the data is limited and it will not support. So we need to find probability Z is less than minus 1.464. It will not give us that. It will give us the probability. We find the reflection and then we read its probability. And 1 minus probability of Z is less than 1.464. Okay, this is how we read it from MF19. So we get this as 0.9258. 1 minus 0.9258, and we'll say that this probability then would mean 0.9918 minus 1 minus 0.9258. So this probability you'll end up getting as 0.847. 0.847. Now remember, this is just for one individual cycle. The question says that 4 are chosen. All 4 have this success, 0.847 to the power 4. And all 4 cyclists have a probability between these times, 0.514. Okay, class, moving on. In a different cycling event, the times can also be modeled by normal distribution. 23% of the cycles have time less than 36, 10% have greater than. So let's just write the notations for this. Okay, again, this time I'm taking times as x, which are normally distributed. I don't know the mean, and I neither even know the weights. But I know that when x is less than 36, the probability is 0.23. And when probability is x is greater than 54, it is 0.1. Okay, now we know that 54 will lie somewhere on the right of the mean, and the probability that it is greater than 54 is 0.1. Probability x is less than 54 will be 0.9. These values can also be read through the normal distribution table. And when we do that, the z value that we get is 1.282. So the value of z is 1.282. Okay, now the next z value is when the probability is less than 36. Okay, so the probability of this being less than 36 can also be found through the standard normal table or MF19. And the z value that we get is 0.739. Again, we will not get the exact z value for this. Why? Because this will yield a negative z value. Why? Because the probability is less than 0.5 and this will lie on the left. So the whatever z value it will have a negative z value. First, we will try to read its reflection. We will say probability of z less than z, I don't know. That probability is 1 minus 0.23. So this is the value of z that I read from the table, which is 0.739. So the value of z will be probability of z is less than minus 0.739 is 0.23. We know that when z is minus 0.739, x is 36 minus mean over sigma. So minus 0.739 sigma is 36 minus mean. And the second equation that we can form is when z is 1.282, the value of x is 54 minus mean over sigma. So 1.282 sigma is 54 minus mean. So once we solve these two equations simultaneously, we'll get the value of once we have these two equations, we have solved these two equations simultaneously. Okay, once we solve these two equations simultaneously, we get our mean and our variance, which is supposed to be 42.6 and 8.42.6 and sigma v 8.91. Class. Moving on to the next question. Question number 7. Let's take it on the next page. Find the number of different arrangements of the 9 letters of the word in which 3 E's are together and the 2 D's are not next to each other. I've given you people a very easy way to do this. If the question says 3 E's are together, we convert them into a single set and consider that for the time being, we don't need to arrange D. So if the three E's are together, what else I will add? L, I, V, R. Okay, these are the five elements that we need to move. For L, I, V, R are four, and this set of E. So these arrangements will yield 5 factorial. Now, how many spots do I have for the D's, provided the fact that I cannot keep them together? This first one, this is the second, third, fourth, fifth, and then sixth. Out of these 6 spots, I can place D in any 2 spots. So I'll just multiply it by 6C2. So I'll just multiply it by 6C2. Because the D's are identical, I don't need to use permutations over here. 6C2. So this should give me the final answer as 1800. So this is one way of doing it. Obviously, we have other ways as well when we find the total and we subtract it from that. Okay. Now find the probability that a randomly chosen arrangement of the 9 letters in the word delivered is exactly 4 letter between the 2 D's. Okay, again 4 letter between the 2 D's. Probably that a randomly chosen arrangement of the 9 letters. Again, we are considering all possible 9 arrangements. Again, we'll imagine that right now we don't have to use these initially. We have kept them aside: E, 3's, and L, I, V, and R. So this should give me 7 factorial divided by 3 factorial. Okay. Then I'll say at which spots can I keep the 2 D's, provided the fact that there are 4 letters between them. One, and the other one is this. This is the first arrangement. If I keep the D in the second position, right? So then 1, 2, 3, 4. This is the second arrangement. Then I keep the D in the third one. 1, 2, 3, 4 over here. And in this fourth position, 1, 2, 3, 4. And so out of these 4, I need to select any one. So 4C1 and keep the D's in any of these positions, and I'll end up getting 3, 3, 6 zeros. But the question is asking probability. So the probability can be calculated number of favorable outcomes, which is 3, 3, 6 zeros, divided by total number of outcomes, which is 9 factorial divided by 3 factorial into 2 factorial. And we get our probability, which will end up being 1/9. Yeah, I hope this is clear. Moving on to the last part. Okay, 5 letters are selected. I have told you people, whenever we have selection and there is a repetition possible, we should always make conditions and then count it. So we'll make conditions in order to avoid error. 5 letters are selected from the 9 letters in the word delivered. Find the number of different selections if the 5 letters include at least 1 D and at least 1 E. So we'll start with 1 D and 1 E and 1, 2, 3, and 3 any other letters. Now, how many options do we have for the remaining? Remember, we are not counting D and L now. So if we take out 3 D's and the 2 L's, we are left with 4. So out of the 4, we need to select 3. So we'll say this will be 4C3. Okay. Then we'll increase their numbers 1 by 1. I'll say 2 D's and 1 E. And then remaining any 2. So I'll add 4 out of 2. I need to select 4 from 2. We'll use 4C2 as well. This is another way of writing 4C2. Okay, now we are done with these, and then I'll say 1D and then 2E. And then again 4C2. Okay, and then I'll say 1D and 3E's. So this will give me 4C1. Okay, with 1D, 1E, 2, and I'm done with that. With 2D's and 3E's. This itself is 1 now. I do not need to select anything. 4C0 or just yield the number 1. 2D's and 2E's are also left. Sorry, I missed out on that. 2D's and 2E's, and then I'll again get 4C1. So 4C1 is 4, 4. We add all of them. Get 4, 4, 3 4s, 2 6s, and 1. 4s, 2 6s, and 1. So we end up getting this as 25. Okay, so that is about it, I believe. So the last question is, thank you. I hope you would have liked it. If there is any query or any problem, feel free to ask me. Thank you. Allah Hafiz.